So if you have to this direction, you're going to have, this is positive 1, sorry. So over here you have strong positive association. If you have over here, you have a strong negative association. If you have here in the middle, you're going to have no linear association. And it's linear association. You could technically have an association that's like a parabola or a curve or something like that, but we don't care about that. So in the middle, next to 0, we'll just say that there's no linear association. And then if you have something maybe like right here, between the two, that's going to be maybe like a weak negative association. Over here, maybe you'll say that one's going to be a weak positive association. So it's kind of on a continuum of where these numbers are going to fall. Over here is good, over here is good, right here in the middle, that's not so good. And the cutoff points between when we say it's linear and not linear is going to be based on our n, which we get to later. Okay, so the next thing they say, it's a unitless measure of association. So if your x's are measured in inches and your y's are measured in centimeters, it doesn't matter what the units are, you can still compare the two of them. And that's because they're basically based off of z-scores, which are also unitless. And then down here, the last thing, the correlation coefficient is not resistant, right? Yeah, not resistant. So if you throw in an extreme value, that doesn't kind of fit in line with the other ones, then it's going to have a pretty big effect on the correlation coefficient, which we'll get to on Monday. Okay. Then they've got some graphs showing you kind of what a scatter plot would look like for different values of R. It's out right here. And I think they have one on the homework where you have to do like a matching, like which one has R equals 1, which one has R equals 0.6, which one has R equals 0.2. You just have to mix and match the two of them. So if you start with just the positive ones, these first three are positive associations because they're going up and to the right. This one, everything's perfectly in a line, so that one has R equals 1 exactly. Like I said, that one's usually not going to happen for us. Unless they're making up numbers to make it happen. This is going to be more realistic for what we would probably see, where it's not perfectly in a line, but you can definitely tell where the line would go through it. So this one has a pretty good association. These dots are pretty well clustered around the line, so that one has a pretty big R of 0.9. Here you can tell it's going up and to the right, but it's more spread out and it's not as clustered together. So there's kind of still a linear association, but it's just not as convincing as the other one. So with this one, they say it's a moderate linear association. In that case, R is going to be 0.4 for this example here. So your R is smaller because they're not as closest to the line as they would be for R equals 0.9. Then they have the same thing, but for a negative association where they're pointing down and to the right. This one, everything is perfectly in a line, so you get R equals -1. This one, everything's not exactly in a line, but they are pretty close. So since they are really close, your R is going to be close to -1. So here they have R is -0.9. Here you can tell it's still pointing down and to the right, but everything's kind of scattered and they're not as close, clustered as closely. So that one, your R is going to be -0.4. So your R, if it's positive, it's going to be pointing up and to the right. If it's negative, it'll be pointing down and to the right. With this one, everything's kind of scattered. There really isn't any pattern. It's not pointing up and to the right or down and to the right or anything like that. So with this one, your R should be pretty close to 0. And then again with this thing, there's a pattern. It's a nice little parabola, but it's not a line. So you can't draw a line through these dots to kind of approximate what they're doing. So in this case, even though there's a pattern, there's no linear relationship. So with that one, our R is also going to be close to 0. Okay, so here's their example. of doing the linear correlation coefficient, and like I said, this is going to be a really long one, so we're not actually going to do this one. I just wanted to point out a couple of things. So they go through for each x and y. Remember, these are ordered pairs, so this 35 and this 5.88, those stay together. They're not going to be separated at all. So they have to stay together because they're paired up. So what they do is they find the average for the x's and the standard deviation for the x's. They find the average for the y's, the standard deviation for the y's. And then up here they take each x value, they subtract the mean, and they divide by the standard deviation. And we've seen that formula before. That's the same thing as the formula for the z-score. So what they're doing basically for each ordered pair is they're finding the z-score for the x's, or they're finding the z-scores for the y's, and then they're multiplying those two z-scores together to get this thing up here. And once they have these values, they just add them all up and divide by n minus 1, so they're kind of taking like the average of those things, and then that's how they get back their R, which in this case is going to be a 0.773 for the drilling data. So it makes sense because here our R is positive, and when we looked at the graph, we noticed that there tended to be a little bit of a positive association with it. It really wasn't all that close to being linear, but we can tell kind of where our line would go. So 0.773 for our line right here. That makes sense. So if you do a line, oops, that's not very linear. If you do a line kind of like that, you can see how the dots are kind of clustered around it. So it's positive. It seems to be fairly linear. We do have these dots that are kind of scattered a little bit further out, so it's really not that close to one, but it's a pretty decent R. We're going to come down here. So that's if you were to do it by hand, which I don't recommend doing. Okay, so now we're going to talk about how to do it on your TI-84, but you have to turn your diagnostic on, otherwise it's not going to give you all of the values that you need. Right? So this is something that you only have to do one time, and then you shouldn't have to do it again unless you like change calculators or your batteries fall out and everything like that. So if you do it just the one time, you won't have to do it again on your calculator. But we're going to access the catalog, so hit the second button and then 0, and that'll bring up your catalog, which is basically every function that you can possibly have. So second button, then down here above, hit the 0 because above that it says catalog. And we're going to scroll down to diagnostic on. They're alphabetical, so you're just going to have to scroll down to the D's. You got two different options. You want your diagnostic on. For some reason, factory settings are to turn it off. So you turn it on, hit enter, it says done. So you have no way of verifying that this was done until you actually go through and do this next problem. Sometimes the TI-83 might not have it. Is anybody having trouble finding the diagnostic, turning it on? Awesome. All right, so now we've turned it on, so we're okay. Got it all turned on. We've got this same group here with our houses and their selling price and their size. We already put these into our L1 and L2, so we don't have to redo that. That's kind of nice. And so what we're going to do, they have find your correlation coefficient. First, put your x's in L1 and your y's in L2, but we already did that. All right, so now we're going to go to stat calc. Stat calc, and I'm going to go down to number 4 for linear regression. We'll talk about why it's linear regression later, but you want to select number 4. Whenever we're in chapter 4, we're going to select number 4, your linear regression. You can enter, and then you can just hit enter again if you have a newer one. So mine looks like this, and I'm just going to hit enter. And as long as my L1 and my L2 are the same length, that should give me back my numbers. If you have a newer calculator, it's going to look like this. It'll pop up and ask you for your X list, your Y list. Your X list is always going to be L1, your Y list should be L2, assuming that's where you put your X's and your Y's. Your frequency list should always be blank for this one. We're never going to have frequency lists in this chapter. So just keep that blank, keep that one blank, and then just hit calculate. You should come up with this one. And then R is going to be the one at the bottom. Anybody missing their R and their R squared at the bottom?